Hey team, it's Mr. Z, and today we're going to look at transformations in function form. Let's dive on in. So in each of these, you might notice that the transformations look slightly different. It's because it's in function form. The rules follow the same. For example, I know that this guy is going to be moving to the right 2. If I were to substitute it into my original one, g of x will look like 1 over x minus 2. When you're looking at horizontal movement, remember it's always got to be in negative form. My mind only is looking at the 2. So let's go ahead and graph this. The way I do it is I look at the original guy, which is 1 over x, and the two critical points are 1, 1 and -1, -1. This is always the case, and I use the horizontal and vertical asymptotes to frame this rational graph. Now, what I'm going to do is I'm going to go right 2. The first thing I'm going to do is move this vertical asymptote. I'm going to move it over 2 spots, and I'm going to represent this invisible line with a dashed line. Then I'm going to move the 2 critical points. I'm going to move this point right 2, and I'm going to move this point right 2. Notice the horizontal asymptote has not changed. If I move it to the right 2, it's just going to extend further in the right. Now, with my asymptotes, I'm able to frame this graph, and I'm able to go ahead and give a quick sketch of what it would look like. Voila! Let's go ahead and look at the next one, shall we? So here we have 2 transformations going on. Remember, I always like to rewrite this as x minus minus 1. This enables me to see that it's going to be going to the left 1 and then down 2. If I were to substitute this into function form in order to see it with your own eyes, g of x would simply look like 1 over x plus 1 minus 2. Now, same idea. I graph my OG1, 1, 1, -1. My asymptotes are at the x and y axis, and I'm able to sketch out the original graph. In order to graph the transformation, I'm going to go ahead and shift my asymptotes. I'm going to move the vertical one left 1, and then I'm going to move the other one down 2. This is going to enable me to frame the conversation. I move my critical point left 1 down 2, left 1 down 2. I'm only moving those points, and I'm able to go ahead and sketch this out. Using my horizontal and vertical asymptotes as a frame, I'm able to give an approximation. All right, next up, what this is going to be doing, this is going to be a stretch. It's going to be a vertical stretch by a factor of 2. What this would look like if I were to substitute it in, it would look like 2 over x. In order to graph this, I start out with my original function. Now what I'm going to do is I'm going to use the coordinates in order to guide me. These 2 points are -1, 1 and 1, 1. I am going to double the output. This is going to lead the transformation or the image to be -1, 1, and it's going to change to be -2 and 2. I multiplied the y value by 2. I'm going to graph these new points, -1, 2, and 1, 2. Boom. Now I know it's going to be a stretch. It's going to be a little bigger. It looks something like so. The last one, let's take a look at it. Well, what's happening? Well, the y is being flipped. This is going to be a reflection across the x-axis. The reason I know is if I have a y value of 2 and I make it -2, it gets flipped. What it would look like if I were to graph it would look like g of x is equal to -1 over x. I start off by graphing my critical point, and I'm looking at my original function. And what I'm going to do is I'm going to reflect it over the axis. A reflection is the same distance. So over here, notice how this point is 1 away. I'm going to go ahead and graph the new point 1 away. Vice versa, this distance is going to be 1 away. And it's going to create a function like so. It is still bound by those asymptotes, but you can see how it's a clear reflection over the x-axis. I hope this helped. This is just a quick review. The idea is that you're supposed to be able to sketch. It doesn't need to be the most accurate. It needs to be a general representation of the behavior of the graph. This is it for now. Ciao.